Hey guys, welcome to Chemistry Lover, and I am with another new question for you. So in this question, it is saying that predict the most stable conformation for one methyl, one phenyl cyclohexane, and all these four options are given. So you have given with all these four options. This is option A, this is option B, this is option C, and this is your option D. So what will be the most stable conformation among all these? Now, to predict the correct answer, we have to know about the interactions involved in all these isomers, and then only we can predict the most stable isomer. So, for that, we have to draw all the hydrogens which are interacting with each other. So, in the next slide, I will show that. Yeah, so you can see. So, in this slide, I just have drawn all the hydrogen atoms which are involved in steric interactions. So A, if we consider A, you can see this molecule or this conformation is quite stable because this hydrogen of this phenyl ring, the orthohydrogen atoms, they are not interacting with any other hydrogen atoms. So this conformation A is quite stable, we can say, although we will see there is one kind of interaction. Now let us look into B. In B you can see, although there is no interaction with the 1,3, so there is no 1,3 diaxial interaction, that is interaction with these hydrogen atoms, but you can see these equatorial hydrogen atom and these hydrogen atom, they are sterically interacting with each other, and here these and these, so they are interacting, right? So there is a steric clash. For molecule C, for molecule C, there is a severe steric interaction. You can see this is 1,3 diaxial interaction. So this is the least stable. This is actually least stable. This is least stable. So we discard this one. We can right away discard this one because in this conformation 1,3 diaxial interaction, 1,3 diaxial interaction is there. For D, for isomer D, you can see there is no such interaction because this hydrogen is now below the plane actually. So this is rotated, this phenyl ring is rotated, and that's why it is not facing these hydrogen atoms. So this is quite stable. Now we have to compare the relative stability of all these three, the A, B, and D. But before that, let us look into uh, a similar looking compound. So this compound, you can see the difference is here we have a methyl substituent, uh, and in this case we don't have methyl, we only have phenyl. Now when we have one substituent, the phenyl, then we can easily say that this conformation will not be there, or its population will be very low because because the phenyl will not prefer to stay in the axial position, right? So it will go in the equatorial position. So this is one equatorial conformation and this is another equatorial conformation. So this is clearly not the most populated conformation. Now between these two, this equatorial and this equatorial form, so in this case you can see, so this similar kind of interaction between this ortho hydrogen atom and this equatorial hydrogen atom, there is a steric clash, and between this one and this one, but here you can see there is no such steric clash because now this hydrogen is here and this hydrogen is on some other side, there is no spatial interaction between these two. So this will be more stable compared to this one. So based on that, you will say that this A will be more stable because phenyl will not prefer to stay in the axial position as it is bulkier than methyl. So methyl, if we compare methyl and phenyl, phenyl is bulkier than methyl, so it will try to stay in the equatorial position rather than in the axial position. Now between these two equatorial position, in this equatorial conformation, you can see there is a steric clash between this equatorial hydrogen and this ortho hydrogen, but there is no steric clash in case of A, so A should be the winner. But here we are forgetting the presence of this methyl group, right? So now if we look, so uh, because this methyl group is present, you can see if we open up the hydrogen atom, so now the hydrogen atom of this methyl group is actually interacting with this hydrogen atom, right? So uh, this is one equatorial conformation, this is another equatorial conformation where just phenyl group is rotated, and this is the axial conformation. Now this equatorial conformation will not be stable as we previously seen, because of this interaction between this equatorial hydrogen atom and this ortho hydrogen atom. So this is not the case, this is not stable, I mean not most stable. And in this case, methyl uh, if methyl would not be there, then this would be the more stable, but because methyl group is there, now this hydrogen ortho hydrogen is interacting with the hydrogen atom of the methyl group, so there is a steric clash. So that's why this is also not the most stable conformation. So we have only one choice, we have to place the phenyl group in the axial position, and this is actually the most stable conformation. So this, if we just compare the population, so if this is 1, this is 2, and this is 3, then 1, then 2, and then 3, so 3 will be most stable and mostly populated. So this question why it is very important, you can see only one methyl group, presence of one methyl group in this position alter the whole story. If methyl group was not there, then story would be different, but because methyl group is there, so the story is something else. And now we can say that so yeah, so we can say that among all these species, yeah, let me, yeah, so we can say that D, so D would be the most stable conformation among all these four. I hope you learned something from this video. If you find this video helpful, then let me know in the comment section and give it a thumbs up. And if you want video on any particular